Hello, dear viewers of the Day TV channel. Today we will talk about American lunar missions. There are several reasons to touch upon this topic. Firstly, the American spacecraft Peregrine Mission 1, which was supposed to deliver to the moon the ashes of some narrowly known individuals, such as writers and actors from the Star Trek series, failed to do so. It didn't even reach the moon and ultimately burned up in Earth's atmosphere over the Pacific Ocean. Additionally, the Americans postponed the Artemis mission, a manned flight to the moon. While they talk about the crew orbiting the moon next year and landing in 26, it can be said with 100% certainty that they will further postpone these missions, likely indefinitely. It's unclear when, as they say, they will return to the moon. This raises a question. If they can't send even a robotic probe to the moon now, let alone a manned expedition, how could it have been possible over half a century ago? They claim to have sent 6 manned missions to the moon with 12 people in total. It naturally raises the question, did they really go there or not? In our studio we have a professional operator, Leonid Konovalov, who has studied all the videos and photographs available about the American moon missions from 50 years ago. From a visual standpoint, he will tell us whether it was real or not. Good afternoon. So, you wanted to focus on the last Apollo 17 expedition, which is called The Last Men on the Moon. Why specifically this one?
The thing is, I wouldn't use the word mission because it implies something grand, colossal.
Like a messiah.
Yes, like a messiah. It's just an ordinary series because everything, except for the rocket launch from Cape Canaveral, was filmed in a studio. So, I would call it all a cinema series. And that's why I would like to denote our conversation with the topic, Hollywood techniques in the Apollo 17 series. Why would I like to discuss Apollo 17 specifically? Because in the first Apollo 11, which supposedly landed on the moon, they showed a black and white broadcast. Then with each new mission, with each new flight, they aimed to more and more amaze viewers, so they wouldn't get bored. That's why Apollo 17 included a lot of interesting elements. The TV camera, which seemingly transmitted images to Earth in real time, was already in color. As we will subsequently find out, there was no TV camera at all. And there was no live broadcast. I will explain this in detail. According to NASA's legend, in this Apollo 17 series, 2 astronauts spent more than 3 days on the moon.
75 hours.
Yes. They entered and exited the lunar module 3 times, collected 110 kilograms of rocks. In short, there were many interesting things. Honestly, the moments that I want to highlight today are very rarely touched upon. For example, in Apollo 11, the liftoff of the lunar module was not shown. But here we see that there is a descent stage and the upper part takes off. The descent stage remains below, and the upper part flies towards Apollo, waiting for docking in lunar orbit. Then they undock, and Apollo 17 returns to Earth. I want to tell you how it was all done.
By the way, I also thought about it. To show the launch, one needs to place the camera on the surface of the moon, so that you can see how it takes off. In the 11th, they didn't bother with that.
Maybe such technology hadn't been invented yet, or they just couldn't manage it. According to the legend, they placed a camera on the rover, drove it about 150 meters away, and filmed from that distance. And an operator on Earth allegedly controlled this camera, zooming in and out. The whole broadcast lasts continuously for 40 minutes, and NASA wanted to convince us that it was all on the real moon. But it's clear that it was all done in a studio. How can you easily see this? For this, I will now show a clip from the 1989 movie Moontrap. Why specifically this year? Because there was no computer graphics yet, and all the techniques of composite shooting or various tricks used in this film are the same tricks that were used in Apollo 17. But initially, I want to add this. Besides the military pilots, there was one geologist in the crew, Harrison Schmitt. There is a well-known photograph. Maybe I'll even start with it. Schmitt is standing near the flag on the moon, and above, we see an image of the Earth. This photograph can be seen in Wikipedia in the article, Moon Landing Conspiracy. The thing is, if you increase the brightness of this image, you'll see some strange angular shadows. Everyone says, how did the shadows come about? The shadow is cast on the backdrop in the studio. But the shadow is somehow distorted and so on. As someone who knows well how to do composite shots, I say, this is cut with scissors. These are the edges of the mask. The point is, the photograph itself is stitched together from two photos. That is, separately, a mannequin was shot against a black background. This is not Schmitt. Usually, to avoid blunders, they used mannequins that could stand still for a long time, an hour, 2, 3. These mannequins were photographed, the film was developed, they checked it. If everything turned out fine, they said, let's move it one step further or make another hand movement, as if it took a step and leaned. A real person simply couldn't stand for 7 to 8 hours in a static position.
They needed professional models who are used to it.
The model needs to go to the washroom, have a smoke. He will leave extra footsteps. Then they'd say, how did the footsteps appear? And there are already plenty of such claims. So, a photo of an alleged astronaut was taken, and in the second photo separately, a flag, Earth, and a reflection in the helmet were taken. That is, there was a sphere with a flag reflected in it. But what's interesting is this. Why is there a black background behind the astronaut and a purple one behind the flag? The thing is, that the Earth was projected onto a movie screen. That is, they have many pictures taken against the background of a movie screen. And to increase its brightness, this movie screen consisted of glass beads. This screen is called Scotch light. Scotch light is used to make retroreflective strips on clothing, so that they brightly reflect light. There are tiny glass beads. So, what's the matter? If you raise the brightness, then the flag is reflected in these glass beads. And since the flag is blue-red, the reflection on the movie screen turns out to be purple. Therefore, it can be seen that the flag was shot against one background, and the astronaut was shot against another background, against a background of black velvet. Then one image was superimposed on the other. I tried to make a correction in the Moon Landing Conspiracy Theories article on Wikipedia, that this is a collage of two shots. Now it says that skeptics claim that these are some shadows, but in reality, this is digital retouching. Nobody knows what digital retouching is. I wrote that this is a collage of two shots. After half an hour, my entry was deleted. I waited a couple of days and wrote again. My text lasted about an hour. That is, there are very vigilant editors there who are on a payroll, and God forbid anything appears in Wikipedia about the moon landing conspiracy that was not coordinated with NASA curators. Therefore, I doubt that Schmitt was on Apollo 17. I assume that the so-called famous astronauts were not even allowed into the studio where the landing was filmed. The real height of astronauts is a giveaway, and you surely know that, unlike ours, they were very tall.
Yes, ours are 170, to fit into the capsule, and those were 180.
Yes, that's about how it was.
America is a wealthy country and can afford launching a 2-meter basketball player.
Yes, but it really turned out to be 2 meters. Look, 180 in height, a helmet aquarium on top, space above the head, lunar boots, and the spacesuit boots. It turns out approximately 1.95 to 2 meters. And the mannequins posing as astronauts were approximately 30 to 40 centimeters shorter. Now I've opened the folder with a clip from the movie Moontrap. I'll remind you again that this is the year '89. There was no computer-generated imagery yet.
More likely, it wasn't used for this movie. CGI appeared earlier. Tron was the first movie in the '80s. More likely, this wasn't a big-budget flick. They used forced perspective. CGI was expensive back then.
It's like two astronauts on the moon.
Argo 1. Moon mission Argo 1.
He stands on the mountain, observes, and sees how the second astronaut approaches him in a rover. You immediately figure out the trick, how this scene of the approaching rover was made.
A small car.
Yes, it's a tiny car. And this standing lunar module, as you can easily guess, is
Forced perspective, right?
it's a model. That is a scaled-down copy. And here it is immediately evident that this is a small toy. And there, some doll is driving the toy car. He is waving a hand. Now this astronaut standing above needs to go down. He says, I need to do something. He takes the first step down, and, I want to draw attention to this, he can't go down. Because in Apollo 17, we will see exactly the same situation. In the distance stands a kind of large model, but you can't approach it directly because it's a toy.
It will become evident that it is small.
Yes, that's why in the movies, they come up with this. Look, he starts walking sideways. Here a new technique is applied, which we haven't mentioned yet. It's shooting at high speed, so that when projected, there's a slow motion effect.
Gravity is 6 times less than on Earth, and he descends slower.
Yes, moreover, it's easy to calculate the difference. The shooting needs to be sped up by the square root of 6. Then it turns out to be 2.46, 2.5 times. That is, instead of the normal speed of 24 frames per second, you need to shoot at a speed of 60 frames per second. Therefore, the moon surface footage that NASA shows was actually filmed at a speed of 60 frames per second. Why do I say that there were no compact television cameras? Because a television camera couldn't shoot at such a frame rate. We have a standard FPS. In our country it's 25 frames per second or 50 half frames or fields. They have 30 frames per second. NASA, so to speak, says, we developed, well, not NASA, but RCI, miniature low frame rate television cameras, 10 frames per second. In reality, instead of a television camera, a regular film camera was used. It was shooting at 60 frames per second. And this is presented as if it were a broadcast.
And what is the difference between TV and cinema? Is it film or cassette?
Yes. The thing is this. When I tell you a bit more about the television camera, I'll tell you how it visually differs fundamentally. The television camera has raster scanning, while the cinefilm does not. Therefore, to create the effect of television, the cinefilm was projected onto a small screen and re-filmed with a television camera. This is how line scanning was achieved. What do we see here? Here, the second actor, having descended from the mountain, is walking towards the first one, whom we see in the distance. And here, on the left side of the shot, stands a landing gear leg. Of course, this is not a real lunar module. This is called a dummy. That is, it's made to look life-size, but it's hollow inside. It's a dummy.
Here they're showing part of it, not entirely. Someone left footprints. Armstrong did.
And this, perhaps, was the first take. The first take was bad. The cleaner didn't sweep away the footprints. And if such a shot was shown on the mission,
every time after a take, they had to clean the footprints in lunar dust.
So, they just went simple. They took a mannequin and filmed it. Done. Move on to the next setting. It's clear that it was the second take. Here's the lunar rover. It's made real size. Maybe it doesn't even drive itself. Maybe in such cases, they attach it to a rope and pull it. And when they need to show distant shots, they use ordinary toys, models, instead of the lunar module and rover. And it's as if a lunar creature is watching them from behind.
Here it can be seen that it's a small toy.
Take the most famous shots of driving on the moon from Apollo 16. There, too, a doll is driving an electric car, and it's clear that it's a doll. Because it sits there and makes a gesture with its left hand like this for 3 minutes. Not once did its hand move during those 3 minutes. And a toy car is driving around the sandbox. And in the background, there,
the spacesuit got stuck. His arm was broken. He was in a cast.
NASA's shills say, well, you must understand that the arm doesn't move and it just hangs in the air because the spacesuit doesn't bend well. Here we show a scene. Look, they're jumping and tumbling, and everything bends.
By the way, I noticed how they jump. There's no atmosphere there, and the lunar soil is sharp. I mean, these rocks are sharp. You could fall and tear the spacesuit, but they calmly fall there and aren't afraid of anything. That's what really surprised me when I watched those videos.
They had to surprise and entertain the viewers somehow, so that they wouldn't get bored watching. Because, for example, if we watch a movie,
I thought about how the viewers could be surprised. There's an advertisement about how Americans met aliens on the moon. If they inserted something alien, then everyone would watch. And there would be Apollo 18 and 19. I interrupted you.
I wanted to say that there's a movie called Apollo 13, which is very famous. There's a scene where after the first broadcast, the viewers started to disperse. They were already uninterested. The thing is, the first live broadcast of Apollo 11 lasted 2 hours and 40 minutes. It's hard to watch over 2 hours of completely blurry and unremarkable shadows that are barely visible somewhere there.
I remember they were broadcasting it on NASA's internal channel. Shall we tell them that they weren't live on air for almost the entire country? Then let's not. It became boring.
For example, in the movie Moontrap, we see the technique of forced perspective, which is known to everyone who's played with it on the beach.
Who likes to hold the sun?
Or the Leaning Tower of Pisa. Or similar things. This is forced perspective. For example, as if it was a car, and cans, from which water or something else spilled out. But in reality, the photographer is shooting small toy models. These models are placed on some plasterboard painted gray, to match the color of the asphalt. As a result, when we shoot these models from a close distance, it creates the feeling that these are large cars. This is forced perspective.
They should have weathered these cars a little. They're brand new. By the way, when they filmed Alien, the director was credited for showing the commercial space tug Nostromo as an old rusty spaceship. It's the same thing here.
Yes, usually they weather the cars. There are special artists who paint them, simulate rust, and so on. For example, in our cinema, as a classic example of forced perspective, I can mention the 1939 movie The Golden Key, directed by Alexander Ptushkov. These small dolls, knee-high to Papa Carlo, are played by live actors of normal height. And to make them appear small, they were placed in the background. Here we see how this scene was shot. So, in the foreground, there's Papa Carlo in the staircase with real steps of normal height. Then there's a wall. In the wall, there's a hole, a cutout is made. And in the distance, on another staircase, there are actors. For them, the staircase is larger in size. The scale of the background in the drawing is also larger to match the drawing of the distant background. However, on closer inspection, one can see the boundary that separates the foreground film set from what is in the background.
The film quality wasn't very good back then. Nowadays, it's digital.
No, if you look, for example, I'll show you.
What I mean is that the boundary isn't very visible. For example, this is a really cool shot. I think viewers should re-watch this amazing movie. I remember two movies from the 30s. This one and The New Gulliver.
That's the same, also Ptushka, 1935.
It's an amazing movie, considering that Hollywood can't offer us anything. There was Apollo. Hollywood still can't provide us with Artemis, so we'll watch our old movies.
Of course, on closer inspection, you can see some boundary there. But for those who don't know, they might watch for a long time and not notice anything.
I think those are realistic shots.
But the effect is stunning. As I'm watching, the effect is just stunning, how they pass by.
They so perfectly align those steps that you can't see the difference.
So, the filmmaking techniques used in the series Apollo 17 are all well known. For example, we talked about forced perspective. Let's now look at the takeoff from the moon. Usually, artists depicted the takeoff from the moon like this. Here is the descent stage. Inside are tanks with fuel and oxidizer. They've been expended, so dragging the stage back doesn't make sense. So, it stays. On top, the ascent stage takes off. What I want to draw attention to is that the artist painted that the splashes fly in all directions. In the footage, we see fragments of thermal insulation. The thing is, initially these two parts are connected. To disconnect the electrical cables of one part from the other, the pyros are firing. What I want to point out is that the artist painted that these splashes or fragments fall, where? Onto the moon. And now let's see how the takeoff from the moon was shown in the movie Apollo 17. Allegedly, a TV camera was on the rover which was positioned at a distance of 150 meters from the module. It filmed the takeoff with a telephoto lens. I will now show you how it's presented in NASA's footage. A few seconds pass, voice is heard, and it takes off.
Do you mean they scatter in different directions?
Everyone asks, where's the flame of burning gases? NASA's response is, we have invisible fuel burning with invisible plume. Fine. Whether it was aerosine or hydrazine, those details don't interest me. As a cinematographer, I'm interested in something else. In what sense? Why didn't any of the debris fall? Where?
Onto the lunar surface?
Yes. Look, I slowed down the takeoff. Follow where these sparks and various pieces fly. For example, here on the left, where are they flying away? Up, into space. Then, after the takeoff, the camera still standing still for several minutes and filming, and for several minutes, not a single piece falls on the moon. They all fly away. Even if you look closely, they fly upward in a parabola. You see, I followed.
Yes, but I'll play the skeptic, the one who supports the idea that they were there. I'll say that maybe they had a high speed, like an explosion, and they just scattered in different directions, and we didn't notice them falling onto the lunar surface.
Actually, the answer is simpler. The takeoff was filmed with the upside-down camera. The lunar module didn't take off from the moon but fell from the ceiling of the studio. That's why these splashes fly exclusively. Where? Down. Then we set up the camera in the usual way, and it looked like this part was taking off. I want to say that no one has yet talked about the fact that the takeoff from the moon was filmed with an upside-down camera. I'm telling you this as a cinematographer because discussions begin about how it was shot. I flipped the shot to show you how it actually happened. The model was hanging from the ceiling, and look, all the splashes and debris fall exclusively downwards.
The ceiling must be high. One has to really capture the moment. It falls with an acceleration of 9.8 like on Earth. That is, you have to capture the moment.
So, what's the matter? Specialists started calculating how this lunar module takes off from there, with what acceleration. This ascent stage weighs, roughly, like a Ford F-750 truck, about 5 tons, 4,600 kilograms. Why mortar launch? It took off in one go. That can't be. First of all, during takeoff, initially, the speed should increase slowly, and then exponentially increase.
Yes, we see that when a rocket takes off and then accelerates.
They say, we had a mortar launch. But I won't discuss the details of the mortar launch. Let those who understand combustion and impulses discuss it. I'm discussing another thing. It was a model, approximately on a scale of 1 to 10. Cinematographers have a rule when we are shooting a model. For example, I'll show a still from everyone's favorite movie, Back to the Future. In the part 3, the train falls into a ravine. Of course, no one would drop a real train. They made a scaled-down model. Usually in Hollywood, they make it on a scale of 1 to 6 or 1 to 10. If we take, for example, a 1 to 9 scale, the model is 9 times smaller, and if it falls from a collapsed bridge, it will fall like a toy. But to give the feeling that a really big object is falling, all cinematographers know that you need to change the speed by the square root of the model scale. If the model is 9 times smaller, then it will be 3 times. Instead of the film speed of 24 frames per second, which is standard sound motion picture, you need to shoot 3 times faster, 72 frames per second. But since I shot at a speed of 72 FPS, and I'm filming the fall, then my acceleration due to gravity will be 9.8. And they need to make it seem like it's on the moon, and it didn't take off instantaneously. Various specialists, enthusiasts, mathematicians, physicists calculate the acceleration from the video and say that it's approximately 2.04 meters per second. And one supposedly official representative of NASA, if necessary, I can name the name, says, no, according to official data and video, the acceleration is 1.5. So instead of 10, we need to make it 1.5. For this, we need to increase the speed even more. According to my calculations, it turns out that we reach a speed of approximately 200 frames per second. This type of film camera shot on 16 millimeters. Here you see the inscription, Millikan high-speed camera. These are Millikan cameras. They allowed shooting at speeds of 200, even 250 frames per second, and even a little faster. With the help of such cameras, you see grandiose shots in the Apollo series when it slowly takes off, and the rocket nozzle slowly rises. This was exactly shot on a 16mm Millikan film camera. I happen to have 16mm film. The takeoff from the moon was shot as a fall on a high-speed camera at a speed of approximately 200 frames per second. Almost no one knows about this yet. I just started to carefully figure it out, watched and said, friends, this is shooting with an upside-down camera. And now, when you watch again how it slowly takes off, you will understand that all these splashes fly down. Pay attention, the splashes are colored. I'll tell you a little more about why they are colored. In fact, NASA characters deliberately peddled the question of the colored splashes. They specifically wanted to showcase this. Because the camera on the rover was of this type, small, compact, and it worked on the following principle. In front of, we would say a matrix, it's a small Vidicon, was a disk of color filters. Here it is in the corner on the left. That is, the camera took one image through the blue filter, through the green, through the red. Since standard television works with fields, it turns out the upper field, lower field, through the blue filter, upper, lower, through the green, through the red. This results in 60 frames per second. That is, from the moon, they broadcast essentially at a speed of 60 fields, 60 frames per second. When our Soviet Luna probe filmed the far side of the moon, in order to transmit a quality image from such a long distance, it took 20 minutes to transmit one image. That is, since we cannot quickly transmit a large volume of information, to ensure good quality, we transmit over a longer period of time. True, when we filmed the far side of the moon, it was in 1959, we transmitted one image in about 20 minutes. And they transmit some crazy volumes in 1 second, which we have only now approached. Why don't I believe in this camera? It roughly looks like this. It was on the Apollo 17 rover, and it was controlled from Earth. They say, on this television camera there was an Angenu lens. I'm just showing what kind of stationary color television cameras there were in those years.
Huge.
This is one of the first such television cameras.
Do you remember the movie Moscow Does Not Believe in Tears? There, the operator in the studio carried such a contraption.
Here's a more or less compact one.
Yes, this is approximately the one he carried.
I wrote a book called, When the USA Admits They Didn't Go to the Moon, in which I thoroughly covered all the television cameras. I explained that yes, there were compact cameras of this type. You see? It consists of 2 parts. Here's the camera, and there's the transmitting device. Magnetic recording appeared around 1956 to 1958. These are just the color television cameras developed by other companies. But the most interesting thing is this. According to legend, the Americans say, we were on the moon for 3 days. Before the lunar module took off, they left the camera on the rover, took a nap for a few hours, and then said, well, shall we go? Come on, let's go. So, this camera is in the sun, and we know that if one side is exposed to the sun, it heats up to plus 120 degrees Celsius. I looked up the specifications of this camera, and it says, it can operate at a temperature, look,
from -10 to +50.
It says, if it overheats. You know, everything used to overheat.
At that temperature, the film will burn.
This is a television camera. They say, we filmed with this compact television camera. I say, how did you film if one side heated up to plus 120, and in the shade it's minus 160? It says, if you work in a warm room, where it's plus 30, you can't shoot for more than 40 to 50 minutes. You have to take it to a cool room. So, even the television camera itself, according to its specification, is not suitable for shooting on the moon. Why don't I believe in this television camera? The fact is, they say, it had an Angenu lens installed. This is a French lens. Here I have a French camera with an Angenu lens. Now I'll show it all in more detail. So, I'm familiar with these cameras and lenses. And indeed, the Angenu lens was remarkable. Look up on the internet, you can find Pierre Angenu. He received many awards and honors. For example, he made the first quality zoom lens that changed the focal length by 10 times, from 12 to 120 millimeters. A 10-fold zoom lens. It was in 1958. So, of course, NASA took the best optics available for shooting. But, what's the trick? I deliberately show 16 millimeters film. The width of the frame is 1 centimeter. And the Americans came up with the idea that they had a lunar television camera, which had the Vidicon frame size, this one, in the middle, exactly the same as for 16 millimeters film. Therefore, visually, it is impossible to say whether this was shot with a television camera or a film camera because the same lens perfectly fits both the 16 millimeters camera and the television camera. Why did they use film cameras? Here I have an 8 millimeters camera. Even the simplest cameras have a knob where you can change the shooting speed. For example, you can see here, 12 frames, 18, 24, 48. So, I can shoot at 12 FPS. Listen to how it sounds. Now I set another speed.
Like a drill.
Yes, I changed the shooting speed by 4 times. So, even for amateur filmmakers, changing the shooting speed is extremely simple. But television always works at a certain standard frequency, which for synchronization is tied to the frequency of alternating current, and therefore the speed cannot be changed.
Provocative question. Why couldn't they put such a small camera on the rover? This is as if they went, not a big one, but a small one.
They say, we had a 16mm film camera. They say there was. I'll show you the picture later. They say that besides the television broadcast for several hours, there were some scenes that they captured on film. We can talk about that some other time. But what I want to say additionally is that this image was projected from film onto this small screen. They have a scan converter. And here is a little black device. I'll show it now. It's on the screen. So, they say, since our slow scan television was non-standard, it couldn't be broadcast. Therefore, it was projected onto a small monitor, approximately the size of a letter sheet. And there was a standard television camera. That's what it looked like. RCATK-22. It reshot from the small screen to convert the image into the standard NTSC broadcast signal used in the USA. And when you shoot film with a television camera, you get a horizontal scan. You know, Americans say that 700 boxes of originals went missing. In reality, not a single box disappeared. It's just that the originals were not video recordings of the broadcast on magnetic tape, but rather film footage. Could they possibly show several boxes of film? But in fact, their originals are high-speed shots taken on film. That's why they say, we lost them, to cover up everything and not show the originals. The photo originals remained, but the film materials or television broadcasts all disappeared.
But they say that they have lost the blueprints for the Saturn V rocket.
One can discuss what was lost and what remained. Anyway, their rocket was completely illusory. It was a mock-up. I want to show how this RCATK-22 camera re-records the image. We see a reel with 16mm film. Here's a small screen, and it re-records the film in macro mode. Where is such a setup used? In the past, in the 50s, 60s, what did they do to show a movie on television? They brought the movie to the TV studio on film and showed it on a special TV projector. Here's what it looked like. And the standard studio camera re-recorded the small window. And they demonstrated the movie directly in live broadcast without recording it on tape. This method was practiced at NASA at that time. I believe that what they showed as a rover camera was just an ordinary dummy, because a real camera would not have withstood that temperature and would not have provided functionality. They strongly emphasized that it was a special camera with 3 color filters. When an object moves quickly, through the red filter it is located here, through green, here, and through blue, here. And it turns out that the moving object is 3-colored. We'll see now that they deliberately shook the camera so that the boundary between black and white oscillated, and so that the effect of decomposition into 3 colors was visible. Actually, you know what? You go to a special effects cameraman and say, here's a bottle of cognac for you. From black and white, make it for me through 3 color filters. He says, sure, I'll do it, come back tomorrow. This is a no-brainer for a special effects cameraman, done using a simple frame-by-frame editing method. The point is this. Right now, I'll show you some very interesting moments. They tell us, look, in the Apollo 17 mission, we see gigantic volumes. It would have been impossible to build a studio of that size. We're shooting from 150 meters away. Here's the small lunar module. I say, of course, imagine if they made a studio the size of a stadium. Could you light it with just one light source, like the sun? Of course not. Let's take examples of large stadiums. There are several thousand lighting fixtures there. And to make just one powerful source? We don't have devices that could do that.
Yes, and it would burn out if you tried.
No, the largest device is at the Polytechnic University. It has a 30-kilowatt light bulb. We can talk some other time about how sunlight is simulated. The most powerful devices are arc lamps. That is, there are two carbon rods, and an electric arc burns between them. This is the most powerful arc light. It has been used everywhere for many years. In recent years, they have stopped using them, but in all Hollywood movies that we watch, during the day, arc light sources are always used to illuminate the shadows. This is the most powerful source of light. Its spectrum is close to that of sunlight. Therefore, it is convenient to work with it outdoors, in sunny weather, to illuminate shadows, and so on. They tell us how such a gigantic studio can be constructed. In fact, the studio is small. Here's what I want to tell you. Using the example of the moon trap, we saw that if the lunar module or rover is shown up close, it's a one-to-one scale and real people. But when they need to show a distant shot, a little model is used. For example, let's take the Apollo 17 broadcast. It is unbearably boring to watch it. I think it's 53 minutes long. I took 40 minutes. Since the television camera is mounted on the rover, they first wave their hands on one side for 10 minutes, then on the other side for 10 minutes, doing something there, like collecting rocks. They supposedly brought 110 kilograms of rocks. You can see colored edges that they specifically make to show how their crafty camera works. Naturally, they show the lunar module almost in full size, but not the full height. And how do you shoot such a lunar module in a studio? Easily. They just put it in a regular studio. Therefore, the close-up shots of the television camera are the shots where a real-sized dummy rover is placed. The television camera is deliberately shaken to show the breakdown into three colors. They stand near this rover for a long time, about 20 minutes. Then I fast-forwarded and cut. Now they are in the distance, and we see how the lunar rover seems to have moved away. They added modern animation and show how they drove on the rover for a long time. They went in one direction, approached the crater, and turned around. They show us this surface area with the crater. Now this lunar rover will circle here. NASA is trying to reconstruct all the feats of Apollo 17. Now I just slightly sped up and show. Now the lunar module is far away. Before we continue watching this video, I'll tell you how the lunar module is filmed from afar. No one knows about it. I'm showing you the secret. First, here is such a picture. Here was an operator with a camera, and he filmed an astronaut up close. Here stood a mock-up of the lunar rover, like in the 1989 flick Moontrap. And in the background was a hole, and in it, a second actor was projected in the distance. That is what I want to say. Here is the diagram. Here is the camera. In fact, it was not a TV camera but a film camera. It filmed this actor. So, they walked back and forth around the rover for a very long time, about 20 minutes. And it turns out that the distance to this painted background is about 15 meters. What is 15 meters? This is a large room, and it is not difficult to make a set of 15 meters in any studio. It is about the size of a basketball court. There is a toy model of the lunar module at a scale of 1 to 10. I will now show you what it looks like approximately at a scale of 1 to 10. So, a small gap is highlighted. We made a diorama here in a semicircle, and therefore, the operator cannot make a circular panorama. He can pan a little to the left, a little to the right, but he needs to show that the actor, that is, the astronaut, enters the lunar module. The broadcast lasts over 40 minutes. They dug around and went. First one climbed in the lunar module, then another. Then they slept there, and then they flew away. How to bring them to the lunar module? For this, a cut in the scenery was made. And in the distance, about 100 meters away, they made a small enclosure, which can also be easily lit with a single spotlight. But the actor walking towards the lunar module, how can he walk?
He cannot walk straight.
He cannot walk straight, so he needs to exit the cut. He will go around the scenery, and at this point, he will enter. So, first they show how the first astronaut moves away from the camera, which is set up on the rover. What is the TV camera doing at that moment? We'll see now. It's so boring to watch that I sped it all up. That is, the camera starts panning. Where? To the ground and to the seat of the lunar rover. Then it seems to accidentally pan up, and bam, the astronaut is already approaching the module. Then the second astronaut also needs to be guided to the alleged lunar module. But he also cannot walk directly. Therefore, the camera, and according to NASA's legend, it was supposed to be a television camera, repeats the same trick. It starts panning down, onto the footprints, again onto the seat, wanders around the seat. Then it pans up, bam, and he's already there. And what's interesting, since the model is in the foreground, they cannot enter it how? From the front. They can only go around from behind. If it's a model, he can't walk in front of it. Being in the distance, he'll always be behind the module. That's why they came up with the version that the entrance to the lunar module is from the back. And they positioned the lunar module so that the ladder for ascent is on the side invisible to the camera. Look, I'm showing a video clip of how their rover approached. The thing is, watching all of this is unbearably difficult. They slowed everything down to show the effect of sand falling from the feet in slow motion. Everything is slowed down by 2.5 times. That's why all the astronauts are walking at 2.5 times slower. It's unbearably hard to watch.
We had a teleplay based on the story The Snow Maiden by Bulichov. They did the same thing there when he climbed into the rocket.
Look, the first astronaut went somewhere. They begin to show us some details. I just sped it up. They show the shadow of the second person. They show details of the rover. The camera keeps moving back and forth for a long time. Then, bam, and the astronaut has already appeared in the distance. He can only walk around the back of the module. Now I speed it up again by 10 times. I sped it up because it's boring to watch. Now they need to let the second astronaut pass too, as if he walked 150 meters and arrived there. Then the camera starts wandering again, showing the footprints, again showing some tire, showing the seat, distracting our attention. I don't know what interesting things can be seen on this rover for 20 minutes. Then, bam, there he goes. Now I'm showing at normal speed, as NASA shows it. That's how he's trudging along in slow motion. Here, you can even see where the division boundary is. They are beyond that boundary.
And you see, the operator keeps panning up and down all the time to show us the color stratification and to showcase that it's supposedly filmed with a TV camera.
Here's what I thought. When Gagarin was launched, the Westerners said, "Tell us who did it. We'll give him the Nobel Prize." We didn't say, but here it's an Oscar. Tell us who did it. We'll give him an Oscar for special effects. We won't tell. This man missed out on an Oscar for special effects.
Maybe this picture should have been drawn in more detail, but the essence is this. If you watch the movie The Golden Key, they use the same techniques there, when part of the set is cut out and we see another actor in the distance. But because it's a small piece, it seems like he's in the foreground and it's just a little doll. In our country, Pushka used these techniques back in 1939.
We could have made a movie in 1939 how we went to the moon.
But we already have the movie Cosmic Voyage.
But there, you can see that it's a figurine jumping, that it's animation.
You know, in the Apollo 15 and 16 missions, too, you can see dolls. The main principle of shooting is that, let's slow down the action by 2.5 times, and then the sand will fall slower from the feet. So, their task was to stomp around as much as possible to scatter as much sand as possible. I sped it up by 2 times to show how the astronaut actually ran. We see that there are no jumps higher than 10 centimeters.
You mean, because the gravity on the moon is 6 times less, with every push he should fly farther and higher?
Higher is okay, but the most important thing is different. Look, he has a life support backpack behind him, and it makes up 2/3 of the astronaut's weight. That is, the astronaut should walk like this, bent over, as if he had a sack of potatoes on his back, and they forgot about that. Sometimes they stand completely straight. I mean, they have a fake backpack behind them, an empty box.
And on the moon, it weighs less. I mean, for example, the cosmonaut weighs 70 kilograms. 2/3 of the cosmonaut, 50. It'll be 10 kilograms.
And also, the spacesuit?
The thing is, modern spacesuits for extravehicular activity now weigh 120 kilograms. The American one weighs even more. In another version, it's 150 kilograms. We can talk about the spacesuit some other time. The lunar spacesuits were so lightweight that they've corrected it now. In the books published in the 1970s, it's written that its weight is only 54 kilograms.
You see? These are technologies not even of the 21st, but of the 22nd century. And they understand that making such a spacesuit is out of the question.
Do you know what the main problem was when they said why they postponed Artemis for a year?
There are no spacesuits.
They showed a prototype, where she picks up a rock. This was under the previous administrator Bridenstine, under Trump. This is a prototype. She picks up a rock. Okay, but there's no protection. By the way, it's a beautiful spacesuit with a big helmet.
But there's still no real spacesuit. They say, why don't we take the engine or the spacesuit from Apollo? It was very expensive. In total, the Apollo missions cost $25 billion. If you convert $25 billion from the 1960s and 1970s into our money, then with inflation, it's about $140 billion. Before the Artemis mission, there was also the Constellation program. They tried to go to the moon back in 2005. To date, 4 times more has been spent than on Apollo, but there's still no result. This astronaut who's running here sometimes forgets that he has a heavy backpack behind.
They should have put bricks in it.
All photographers, when they use a telephoto lens, know that it's made of glass and very heavy. Weight disappears, but mass remains.
For example, a log in the water doesn't weigh anything. But try to swim up to a log in a pond. Sometimes there's a log floating there. Or a boat. It doesn't weigh anything either. Try to push it with your hand. You won't be able to, because it has mass. It's the same with these videos. Now he's going to cover the camera with a cap. The camera is made of foam. Look, he's here now.
It's allegedly being filmed by a TV camera, and you can see that the backdrop is painted.
Look, it's a foam camera.
They deliberately shake the camera.
Do you know how operators make cameras shake?
If you need to simulate an explosion in the shot, you need to hit a leg of the tripod with the edge of your palm, and then the camera will shake. So, here the operator bangs by the edge of the palm, the camera wobbles, bang, by the edge of the palm. See how they create shake.
In the movie Saving Private Ryan, they shook the camera to make the audience feel close to the action. Same here.
You can see that it's a fake camera made of styrofoam. It has no weight.
It feels like there were two different filming crews for the photo and video shoots. Because those who shot the video were saying to scatter as much sand as possible, while others were saying not to do it.
What's the matter?
For example, we saw the lunar module when a powerful engine with a 5-ton thrust was working. Sand should be flying in all directions. We remember when the Starship took off from the launch stool, it completely demolished the giant concrete structure. Here, at least there should be dust.
Why is there no dust? Because it's an upside-down mock-up, so there can't be any dust.
I thought they should have sprinkled dust on top.
But where would the dust go?
When we launch it, it should fly off into space. An artist at NASA drew all these pictures. You see, there are splashes and streams of hot gases. Chunks, scraps or disturbed small stones are flying off.
They have nothing, it didn't work out. At first, they tried making toy models with gas burners and releasing gas, like in the 1950s movies, for example, Destination Moon.
But you can see it's a gas burner.
They tried doing it like that and even showed them live as a reconstruction of the moon landing. Look, we're showing a toy model with a gas burner.
This is us telling what's happening on the moon at that moment. We briefly touched on some episodes of the lunar epic.
They had a mock-up.
I recognize this. It's Mythbusters.
I think this mock-up is approximately 1 to 10 scale. So, the width of the module at the landing gears is 9.5 meters.
That means in reality, here it should be about 1 meter.
This is about 1 meter. So, in reality, the mock-up was like this.
Next, the model falls. If we look at the NASA legend, it takes off upwards and then tilts at a 50-degree angle and flies in an arc. Therefore, when they filmed the takeoff, if we calculate how long the fall lasts, it turns out it was only from 20 meters. Then they attached the model to, what's it called, bungee jumping.
You mean when they jump off a bridge with a rubber band?
It just falls down, and then it starts flying in an arc.
They say, it takes off, gains horizontal speed, and flies like that.
So,
In their version, the lunar module takes off, tilts, flies, and we see the landing site where the landing stage remained.
Hollywood screenwriters have come up with all sorts of things.
You're talking about using a rubber band, but it would be visible.
Well, why not, against the black backdrop of space, a black rubber band, well, a small wire, perhaps.
It's like looking for a black cat in a dark room.
This is the second detail to discuss, how it was done.
Later, I'll tell you how the takeoff was done in Apollo 15 and 16.
There, too, it fell down, but there was a sloping set on a vertical wall and such a bend. That's why it fell, and debris fell onto this bend.
Perhaps it makes sense to meet again, and you'll tell me about other missions. What else can you say about Apollo 17?
If we summarize what's there, we can look at the photos. In many photos, there are ordinary dolls sitting on the rover.
There are many passes made, hundreds of photos. The camera is filming from a first-person perspective.
This can be discussed.
But the main thing is that, analyzing short clips like, for example, the module's takeoff and the stomping around the rover, we see that in reality, all of this is just commonplace cinematic techniques, filmed not even with a television camera, as claimed by NASA.
Perhaps such a television camera didn't even exist.
Everything is shot with a 16mm film camera at very high speed. When they're just running, it's at a speed of approximately 60 frames per second, and when simulating a takeoff and needing to make it appear as if the ascent stage is slowly rising, it's at a speed of almost 200 frames per second.
Of course, this involves the use of models, forced perspective. We see that during takeoff, there's no dust. All the debris flies upwards, so they try to show the beginning of the ascent with a high zoom. There was a six-fold zoom lens. They zoomed in as much as possible. Therefore, we don't see where the splashes fly further, and when it seems like they've taken off and ascended, they zoom out and show us a wide shot. Look, there's nothing there. So, these are just models shot in a studio.
There's nothing complicated about it. The studio with this model was slightly larger than a basketball court, and it's easy to light up such a space with powerful lights. It's not difficult at all.
Therefore,
in all these missions, in these series, we see typical Hollywood techniques.
In these shots, there's nothing unusual that could only be filmed on the moon. For example, due to the weak gravity on the moon, you need to move by strongly leaning forward, but they run in a purely vertical upward position. We can talk about how one should move on the moon some other time.
There were lunar gravity simulators, and at the beginning, those who were supposed to land on the moon, including ours, went through this simulator.
It's a crafty suspension of the astronaut on ropes.
Yes, I've seen that picture. Well then, I think we can finish for now, and come back next time to other missions and the details of how all of this was filmed. Thank you very much. Dear viewers, write comments under the video about what else you want to learn. I think that in the next episodes, we'll talk about other missions, what techniques were used in creating the visual effects of all this. Thank you very much. Take care. See you soon.